Find whether the following series is convergent or not and absolutely convergent or not. You are watching Brain Exploders, the world where brain starts working. Let us first see what is a convergent series. An infinite series u1 plus u2 plus u3 and so on up to infinity is said to be convergent if some of its first n terms tend to a finite limit as n tends to infinity. In simple words, we can say that summation n is equal to 1 to infinity un lies between two finite values, means it is neither tending to minus infinity nor tending to plus infinity. Absolutely convergent series. A convergent series is said to be absolutely convergent series if the series formed by absolute values of its terms is also convergent. If a series is convergent but not absolutely convergent, then it is called a conditionally convergent series. For example, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on up to infinity is a convergent series, but 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 means series formed by the absolute values of above given series is divergent. It means this above series is a conditionally convergent series. Now let us see the nature of summation n is equal to 1 to infinity cos n upon n. If we can prove that summation n is equal to 1 to infinity cos n is a convergent series, then it will imply that cos n upon n is also a convergent series. For this, we will start with 2 sine 1 by 2 cos n. You can also start with 2 sine 1 or any other value. So it can be written as summation n is equal to 1 to infinity sine n plus 1 by 2 minus sine n minus 1 by 2. On expanding the summation, we get sine 3 by 2 minus sine 1 by 2 plus sine 5 by 2 minus sine 3 by 2 plus sine 7 by 2 minus sine 5 by 2 and so on. You can see that sine 3 by 2 gets cancelled out, sine 5 by 2 gets cancelled out, and in this way many terms will get cancelled out. So last term will be like something limit n tends to infinity sine n plus 1 by 2, and here we have sine 1 by 2 remaining, so let us write this minus sine 1 by 2 also. Now this first term will also lie between a finite value, means minus 1 and plus 1, and this second term is obviously a finite value, hence this given series is convergent. Since the multiplication of a constant term or division of a constant term doesn't matter for the convergence and divergence, it means summation n is equal to 1 to infinity cos n is also convergent, and hence summation n is equal to 1 to infinity cos n upon n is also a convergent series. Now let us check the convergence of mod cos n upon n summation n is equal to 1 to infinity. For this, we will start with mod cos n upon n. Since n is a positive number, so it doesn't matter whether we apply mod on n or not. This term written here is less than or equal to cos square n over n. Let us see how. Since we know that value of cos n lies between -1 and 1, means mod of cos n will be less than or equal to 1. Now if we multiply the mod of cos n both sides, it will give us the result that cos square n is less than or equal to mod cos n, and this is how we have written this. Now if we multiply 2 in the numerator and denominator, we can rewrite the terms something like this. We know that cos 2n is equal to 2 cos square n minus 1. From here, in place of 2 cos square n, we can write cos 2n plus 1. So we have cos 2n over 2n plus 1 over 2n. Now as we apply summation both the sides, we have expression or equation something like this. Okay. Now this summation can be applied to the two terms separately. And 1 by 2 can also be taken as common, as it is a constant. Now this part can be proved to be convergent by the method we have just discussed for cos n upon n. And here this series means summation 1 over n from 1 to infinity is 1 plus 1 by 2 plus 1 by 3 and so on, which is a divergent series. So it is diverging, means sum of an infinite value and a finite value is obviously a infinite value, means this series over here is also divergent, means mod of cos n upon n summation n is equal to 1 to infinity is divergent. Hence our given series is conditionally convergent series. Don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.